Okay, I'm going to try and run through a lot of the different things that we did this week that are going to be on our test. First, I'm going to start with the quizzes. So I know we talked about the quizzes during class time, but just in case you missed going over the quiz in class, we had 2 quizzes. Essentially everything that's on the quiz will be on the test. So on the first quiz, every single one of these, all 9 of these, are on the test. So make sure you study them. Again, definitions straight from the book. We're going to go through these. I highly recommend when you do these, use the definitions and descriptions, and then find the word that goes with it. If you read the word and then try and find the definition, you're going to be reading all these and then have to keep rereading and keep rereading and keep rereading. It's easier to do a definition and then find the one word and just skim it. So, for example, going down this, we have the first definition, part of a line that consists of 2 endpoints and all points between them. Well, again, it has 2 endpoints. This must be a segment. So segment was number 9, so A goes down to number 9. Then we have a location and no size. Well, that's a point. So point, that's B. Then we have, for C, point, well, don't even need to look at all the writing. I have this statement right here. That's adding 2 segments. If we add 2 segments and set equal to another segment, that's segment addition. So C is segment addition, number 6. Identify, an infinite number of points on a straight path that extends in opposite directions with no end or thickness. That's a line. So line D, that's number 2. For E, part of a line. So part of a line, I should automatically think segment or ray. Well, I already used segment, so most likely it's array. Let's see. Part of a line that consists of one endpoint and all points of the line on one side of the endpoint. So yeah, that's definitely array. So 7 is E. Again, looking at this, I see the angles being added instead of equal to something. So this is angle addition. So 8 is F. G, if an infinite number of points and lines on a flat surface, that must be talking about a plane. That's G for 5. Formed by 2 rays with the same endpoint. So that's going to be an angle. When you have 2 rays sharing an endpoint, that forms an angle. So H is 1. And then finally, points on the same line. When anything on the same line is collinear, so points on the same line, that's collinear. That'd be I for number 3. And that is the first quiz. Again, you'll see every single one of those on this test, so make sure you study this vocab. The second quiz, there was 2 different versions. So again, it's very important that you know how to do these. I'm not going to go back through every single step of this. I'll post the answers. Again, here they are. We did them in class. There was 2 different versions, so take note of different versions. But essentially, the top 2 are segment addition and angle addition. So you have to be adding the 2 segments together. So here we added them together. They gave us an overall length for the whole thing, so we were able to add the 2 segments and set it equal to the entire length. So we took what we added together, set equal to the whole length, and then solved. Here we added 25, there we added 9, divided by 5, divided by 4. Again, we had 2 different versions, so they're both there. On number 2, again, I can't say that these are word for word on the test, but you'll have some similar to these on the test. This one, you have a straight line. A straight line has to be 180 degrees. Therefore, we're adding them up, saying them equal to 180. Adding them up, saying them equal to 180. Once you do that, again, combine your like terms, and then it's algebra. So bring the value over to the other side by adding it, divide off the value. X in both cases was 46. You had to plug it back in because it said find PQR. So measure of angle PQR, you had to plug it back in. So you got 2 different answers depending on which quiz it was. One was 132, one was 133. Then we had the constructions. This is what the final thing should look like with the constructions. I'm going to go ahead and run through them real fast so that you can see them in case you missed them during class. Because again, both of these constructions are on the test exactly as they appeared on this quiz. So if you practice this over and over, you should be able to get all the points for these 2 questions. So I'm going to show with both types of compasses. So again, you have to use a compass and a straight edge when you're doing constructions. Those are only 2 tools. You never use any type of measurements. So here we open the compass to the length of AB. We come to M. We mark off that length. So this is point N. Then we have to make sure our compass is open at least more than half that length. We can just leave it that length, that's fine. Swing it above, swing it below, go over to N, do the same thing, above, below. You find 2 points of intersection. Both of those points must be on our perpendicular bisector. Line it up, draw it. That's all you have to do. If you want to mark it so that you're showing that it's a perpendicular bisector, you can put the little mark for perpendicular, and you can put the marks for those two segments being congruent, and that's it. Same thing with the bullseye compass. If you go from one endpoint, open it up to the other endpoint. So we have that length on there. Place the bullseye on M, mark off N. Again, swing an arc above and below from both M and N. So that's from M, now over to N, same length. Not changing anything on my settings. Compass moved a little bit on me, but that's alright. So there's my perpendicular bisector. Now, copying an angle and bisecting an angle. I reworded this a little bit on the quiz so you don't have to worry about going through point Q, but for the purpose of what this quiz said, I'm going to use point Q. We have to start off with an arc through our original angle and what's going to be our new angle. So, let me use the other compass first. So, open this compass up to the length of PQ. Swing an arc. Go to G. Swing an arc. Notice, I didn't hit that line, so in order to complete this one, I'd have to extend this line, because now we have to measure the intersection between those two rays of where this arc's intersecting. It's a very important step. So I mark it off, and line it up. And that looks off to me, so let's check it one more time. I think my compass may have moved slightly. Oops. One more time. Having a piece of paper underneath also helps because it'll keep your paper from moving so much. Right now, I only have one sheet of paper here, and that's why it's moving so much on me. Once you have that, you then go from point, swing an arc out in front from both of those. Wherever they intersect, that should be the angle bisector. And those two should be congruent. Alright, let's do it again with the other compass. So now, this is with the bullseye compass. We have the arc. We're opening this up to the length of PQ. We go over here to G, same arc. Again, it wasn't long enough this ray to hit that arc, so we can extend it. We open up our compass to the width of the two intersections of that arc on the two different rays. We copy it over to point Q, so go to point Q, mark it off. Again, if I mark this properly, this should actually be point R now. And then draw my ray. From each of those points, I want to bisect it, so I'm swing my arc out in the middle of the angle, so on the interior of this angle, I have two arcs that intersect. It should be the same length from both of those points, both R and Q. Draw my ray from the vertex to that point. So this has now been bisected. So those are congruent. And that's it for the second quiz. Now we're taking a look at the review. So the review that's in the book is the one I'm looking at first. So this is the review that's in your textbook on pages 64 and 65. So this is the one that I assigned for homework tonight. I'll also post this blank copy to Edsby so that you can use this if you can't find it in your textbook. But the first question, find each value. So ln is 45, so this whole thing is 45. They gave us these two lengths, so we can set up an equation so that we're setting these two equal to that 45. So 45 is equal to, and we're adding these two equations together. Plus x plus, so combine all your like terms. So 45 equals 4x plus 21. Subtract off the 21, that'd be 24 equals 4x. Divide off the 4, that'd be 6. So x is equal to 6. They want us only to find x, so that's our final answer. Then for number 10, so they told us SR is, RS is 27. They want us to find SQ. Well, we already have two things that we can set equal here. They only gave us this length. They didn't give us the whole length this time. So if this is 27, we know that this should also be equal to 27. So 12x minus 21 equals 27. Solve, so add 21 to the other side. That'd be 48. Divide by 12, x is 4. We're not stopping there. They want us to find QS. So now we're going to take 4 and plug it back in. What are we plugging in for? Well, we want this whole line QS. So we actually have to do this whole line. So let's go ahead and add these up. We have 9x plus 12x minus 21. That's the entire line. Combine your like terms here. 9x and 12x, that's going to be, oops, I wrote that wrong. 21. Oh, I guess I can just write the one over here. 21x minus 21. Again, we had the 4. That's what we got. I went ahead and combined it like this first. You could have also plugged it in and then added the two numbers together, but I just like combining these first. 21 times 4 minus 21. 21 times 4 is going to be 84. Minus 21 is going to be 63. So that's our answer for number 10. Now over here, they gave us a couple different measurements. Now each one is its own separate question here. So you really should only use the diagram for each one. All right, this one for so this information based on the diagram, this information based on the diagram. You shouldn't carry it through between problems. So let's see, EBG. So that's this one right here is 60. FBG. That's saying that that's 60. Oops, sorry. No, I said that wrong. This whole thing is 60. From here to here is 60. FBG is 2 times the measure of EBF. EBF. So essentially, if this was x, this would be 2x. And they want us to find EBF. So first, starting with the information that we have up here, we have 11. X plus 2x would have to equal 60. So 3x equals 60. Divided by 3, x is 20. Now that we have x is 20, we need to plug it back in. EBF, well, that would just be the x, so that one's 20. On number 12, ABE. ABE, so that's saying this whole thing here is 64. DBE is what they want us to find. Well, look, they have the two congruency marks here, so this one and this one are congruent. If those two are congruent, we need to split this. So 64 divided by 2 is 32. So that's each of those angles is 32. Then they gave us GBH. GBH is 28. They want to know GBC, which is the overall angle. Well, if this is 28, this is also 28 because those two are marked as congruent. So together, we need to add those up. 28 plus 28 equals 56. Number 14, point K is located at 7 on a number line, and JK is equal to KL. If the coordinate of L is 23, what's the coordinate of point J? Alright, so point K is located on a number line. J, K. So let's draw ourselves a number line. Let's see, L. Got to picture what this would look like. So here's J, here's K, and here's L. And it said K is at 7. It said these two are congruent, or equal. If the coordinate of L is 23, what's the coordinate of point J? So if we're going the opposite way here, the difference here between 7 and 23 is going to be 16. So we got to go 16 in the opposite direction. So we're actually going to have to subtract 16. We're going in a negative direction. So the distance is still 16, but we have to subtract the 16 to go backwards. So subtract 16 from that, you'd be looking at negative 9. Right? Yeah, negative 9. So J is at negative 9. All right, and number 15. Copy each segment and construct the perpendicular bisector. So on here, same essential thing that we were doing before. I'll copy this first one using this compass. I'll copy the other one using the other compass. So first thing we need is a line to copy it onto. So I'm just going to use a straight edge, draw a line. Mark a point as, I'll call it S prime for now. So now I need to find T prime. So I got that length. Copy it. That'll be my T prime. And then I need to bisect it. So from both those points, so I can arc above and below. Wherever they intersect, line them up with a straight edge. And that's that one. Do the same thing for UV. So I'll do that one over here off to the side. You need to draw a straight line first. Again, it doesn't have to be facing the same direction. This is going to be U prime. I'm going to use my compass, open up to that setting. Alright, come over here, mark it off. This is going to be V prime, and then bisect it. So swing an arc above and below. Go to V, do the same thing. Above and below. And that's it. Now, on the next one, we're copying an angle. So, I'm going to draw a ray to start off. You need a ray to copy it onto. We need to swing an arc so that it goes through both sides of this angle. Pick a point to start from. I'll call this one K for right now, or K prime. I'm going to swing that same arc. Then I need to open my compass to the setting of that width. Now, again, we're doing wherever this arc intercepted. So if your arc intercepted further down, you're going further down. I'm not going here because this is the end of the arrows. I'm going there because that's where my arc is intercepting them. A lot of mistakes on the quiz because people went to the ends of the arrows no matter what. Alright, So that was copying the angle. Then it wants me to bisect it. So from each of these points, our arc was intersecting the two rays. Swing an arc out in front. Line up that intersection with our vertex. And that's going to bisect our angle. Doesn't matter which direction you draw it. Again, the one on the test will be just like the ones on the quiz. Alright, using the other compass. Again, start off with a line for a ray. I'm going to make it go a different direction completely this time. So there's L prime. I'm going to swing an arc so that it goes through both of my arrows, both of my rays, I should say. Swing an arc over here. Open my compass to the setting to where it's intersecting. Come over here to my one intersection that I have. Swing that arc through. So now I have those 2 points. I'm going to extend this line all the way through. From those 2 points, that's going to be where I'm swinging my arc out in front to now bisect it. So I've already done the copying the angle part. Now I'm bisecting the angle and complete the line from the vertex to that point. Again, these are congruent. I don't know what happened to... Oh no, that's 17, that's 18. Okay, 19. Why must the compass be longer than half the segment width to draw a perpendicular bisector? The arcs would not intersect if they're not more than halfway. Arcs will not intersect if not more than halfway. So here's an example. Here's a long line segment. If I wanted to bisect it, but I didn't go more than halfway, say I swing an arc both above and below that line, both above and below this line, those arcs are never going to intersect. I need them to intersect somewhere in the middle so that I can bisect it, just like they did up here on this one. So again, how would you fix that? You'd have to make it longer than halfway. And you need 2 points, so it can't be exactly halfway either. Because if they're exactly halfway, they're only going to intersect at 1 point, and you need 2 points to draw a straight line. There we go. On the next one, number 20. Model with mathematics. The sides of a roof meet at a 120 degree angle. A strip of wood extends down from the vertex so that it bisects the angle. Draw a diagram of the roof with the bisecting strip of wood. So the sides of a roof meet at a 120 degree angle. Alright. So, this is getting a little more complicated. We actually have not done enough to do that one yet. We will, but not for this test. You will not have to do that. You'd have to know how to create a 60 degree angle. I'll show you real quick how you can create a 60 degree angle. So, if I was to draw a line, and then set a length, it doesn't matter what arc I use. I'm going to swing an arc. If I keep the arc the same and go to that point and mark it off, this is going to be 60 degrees. If I go one more time from where I just marked that, it would be another 60 degrees. So this line would be 120 degrees. Then if we bisect that, well, we don't really have to draw it again. Again, I still have the measurement on here, but I'll just show it. Notice where that mark was, that's halfway because I said that was 60 degrees. So maybe bisecting it. Again, don't worry about that question. I'm not going to ask that on the test. We'll get there when we talk about constructing an equilateral triangle. All right. Last part of the review. This is now 1-3. Find the midpoint of and length of each segment. So, on here, length of EF. So, we're trying to find the length from there to there and the midpoint. Well, midpoint formula here. Let me just do our work off to the side. We're taking an average of the x's, average of the y's. So we have, let's identify some points here. This is at -3, +2. This point is at +1, +3. This point is at 5, 1. And this point is at 1, -1. So for 21, the midpoint, we're doing these 2 points, -3 plus 1 divided by 2, 2 plus 3 divided by 2. Again, this is finding midpoint. -3 plus 1 is -2. That's 5. Divide. And our midpoint is at the point -1 and 2.5. For the distance, again, we can use distance formula. Plug everything in. Our x values go first. So we have 1 minus -3 squared plus 3 minus 2 squared. You could also do this using Pythagorean theorem. That's going to add because those change to positives. Minus negative becomes plus positive. So 1 plus 3 is 4. So we got 4 squared. 3 minus 2 is 1. So 1 squared. This is 16. That's 1. So we got the square root of 17. Now we could leave it like that, or we could simplify it. Again, if you do this any further, it's not going to come out to a whole number because that's not a perfect square. So that could be our distance. So that was for 21. For 22, F to G. So same thing. We're taking an average of these. Now, if you can do the average in your head, you don't have to show every step. But again, if you show your work and say you get the wrong answer, you might be able to get partial credit for some of your work. If you don't show any work, then you can't receive any credit. So on here, 1 and 5, if we average these, 1 plus 5 is 6. 3 and 1 is 4. So I'm not showing every step here this time. 6 divided by 2 is 3. 4 divided by 2 is 2. That's my midpoint. Over here, distance. Again, you can do Pythagorean theorem if you want to. So let's change this out to our C value. Because C would be like your distance, so F to G. And then if you're doing Pythagorean theorem, you need an X and Y. So the change in our Y there is 2. Our change in our X is 1, 2, 3, 4. So we could say, for Pythagorean theorem, if you want to use that instead, C squared equals 2 squared plus 4 squared. 2 squared is 4. 4 squared is 16. Add them together, you get 20. Square root of 20. That doesn't come out to a whole number once again. So if we wanted to simplify it, we could. We could leave it like that. You could reduce it or simplify a radical, which that splits into 5 and 4. So going back to algebra now, 2 radical 5. I am not going to ask you to simplify a radical on a test. Only giving you whole numbers for this test. Alright, let's do 23. 23, same idea, G to H. Again, midpoint, it's an average, 1 and 5. 1 plus 5 is 6. 6 divided by 2 is 3. For the y's, -1 and 1, add them together, you get 0. 0 divided by 2 is 0. That's my midpoint. If you want to do some combination of distance and Pythagorean theorem, that also works. So let's say distance equals and then I'm just doing the change. Technically what I'm doing is change in x squared plus change in y squared. It's the same thing. Here, maybe I should also give you the distance formula up here at the top. Distance formula is actually x2 minus x1. Oops, I didn't mean to put that up there. Not squared. x2 minus x1 squared plus y2 minus y1 squared. Alright, again, whether you do that, whether you do Pythagorean theorem, or some combination in between, this also works. So again, you can do a lot of it by looking at the chart. So here we have our 2 points, our 2 x's. If I find the difference there, difference between 1 and 5, that's going to be 4. Negative 1 and 1, the difference there is 2. So 4 squared is 16, 2 squared is 4, 16 and 4 is 20. This one also happens to have the same answer as the last one. So again, could be 2 radical 5. If you wanted to change it to a decimal, you could change it to a decimal. Alright. The next one, EH, 24. E to H, we have average of these two. So negative 3 plus 1 is negative 2. Negative 2 divided by 2 is 1. 2 and negative 1, that would be negative 1. Positive 1. Positive 1 divided by 2 is 1/2, or 0.5. So either that or 0.5 would work. That's our midpoint. For the distance, again, the way I just did it over here is the way that I normally do it. But if you want to just plug into your formula, that's fine too. So we have from negative 3 to 1, that's a difference of 4. 2 to negative 1, that's a difference of 3. Now, later in the year, we will learn, using Pythagorean theorem, there's certain triangles that you can have that will always make the same thing. That's 3, that's 4, this side's 5. Don't actually have to do work once we learn about Pythagorean triples. But for right now, again, if I plug into my distance formula, 16 plus 9 is 25. Square root of 25 is 5. Just like I said earlier. So those are the answers. Now, 25. What are the coordinates of the point 2/5 of the way from H to E? Well, you have to take the, what is H? H and E. So from H to E. So we're going from here to here. First, you got to take the distance of each of the parts separately. So the 4 and the 3. We have to do 2/5 of it. And then whatever we get for that, add it back to the coordinates of H. And again, direction is important here. So we're going to the left, which is negative, and up, which is positive. So the change for X in is 4, and it's going in the negative direction. The change for Y, it's in a positive direction of 3. If I multiply those two numbers by 2/5, and multiply the number by the top, divided by the bottom. So negative 4 times 2 is negative 8. So we get negative 8/5. If you want to change it to a decimal, you could. 1/5 is 0.2. So 8/5 would be negative 1.6. For this one, again, multiply by the top, that's 6. Divided by 5, so that's 6/5. 6 divided by 5, again, 1/5 is 0.2, so we have 1.2. Now, that's how far we're moving from H. So we need to add these values back to our original H value. So H was at 1, negative 1. we're going to add, for the x value, we're going to subtract because we're going backwards, minus 1.6. And for the y value, we're going to add 1.2 because we're going that way. So now, our final coordinate for this one, subtract that, you're at negative 0.6. And for this one, you're at positive 0.2. So negative 0.6 and positive 0.2. The numbers look a lot nicer on the test for that type of question. Number 26. Say models her neighborhood on a coordinate plane so that her school is at 8:12 and stores at 14:3. What are the coordinates of a point halfway between the school and the store? So what are they looking for? They're looking for midpoint. So midpoint of that, you're taking an average of those 2 points. So I'll show my work again this time. 8 plus 14 divided by 2. 12 plus 3 divided by 2. Again, average of the x's, average of the y's. Add those together, you get 22. Divided by 2, that's 11. 12 plus 3 is 15. 15 divided by 2 is 7.5. So that's our answer for 26. All right. And that is it. So that was that review. The other review that I'm posting online is this one. Now, this was done with geometry regular. They went in slightly different order than we did, so not everything applies. Notice I've crossed off all of those and all of those. There's only a couple definitions that you need. Coplanar, I've talked about it in class a few times. It's not actually on the test, but coplanar means that you have points on the same plane. Points on same plane. Opposite rays that point opposite direction form a straight angle. All right. So rays point in opposite direction form straight angle. All right, moving on. On this one, select the statements that are true. So, length of AB is -3. No, that's not right. You can't have a negative length. Distance is always positive, so that's wrong. Distance from B to C, that's another way of writing distance. You do the absolute value of 6 minus 1, that would be correct. On C, AB plus AC equals BC. No, that's wrong. These two should add up to the total. Second one, now that's correct. This one plus this one equals the overall, so D is correct. The length of BC is 6. BC, well, C's at 6, but we'd have to subtract 1, so it's 5. That's wrong. Also, these two, again, I already have them crossed out, but again, don't get confused. Those are not on our test. We'll cover those in the next section. All right, now, number 4. Find the measure of DC and AB. So we want the length of DC, the length of AB. Again, you can use Pythagorean theorem or distance. I like Pythagorean theorem. So we got difference of 2, 1, 2, 3, 4, 5, difference of 5. So we could say c squared equals 2 squared plus 5 squared. That's 25. Add them together, you get 29. So you get the square root of 29, which does not come out to a very nice number. So I could leave it like that, or I'd have to round a decimal. For the other one, let's go ahead and use our distance formula this time, just so we see a variety of things. So this is at 0, 3. This point's at 5, 1. So distance formula. Oops. Square root of 5 minus 0 squared plus 1 minus 3 squared. That's 5. 5 squared is 25. 1 minus 3 is -2. -2 squared is 4. Add them together, we also get 29. How about that? They're the same thing. And notice, if we compare these two dimensions, this is 2, this is 5. Same as what we had over here. If your two legs of two triangles are the same, the hypotenuse would have to be the same. So again, another reason why I like Pythagorean theorem. Name 3 pairs of congruent parts. We have angle, this angle here, this angle here, and this angle here are all congruent. So we can do this a couple different ways, but let's say angle J, N, K, using 3 angles because there's more than one angle coming off a vertex, so I can't just do one, is congruent to angle NMK. NMK. Still sticking with that idea, this angle and this angle are also congruent, so angle NMK, NMK is congruent to angle KML. KML. These two are congruent, so angle JKN is congruent to angle KNM. KNM. Again, all based off the congruency marks there. Find the coordinates of the midpoint of PQ. The same thing you also have to do with segments on the test. Find the coordinates of the midpoint of PQ with endpoints at there. So, average, -8 plus -2 divided by 2. 3 plus 7 divided by 2. That's -10, so that's -5. That's +10, so that's +5. That'll be our final point. If S is the midpoint of RT and R has the coordinates of this and S has the coordinates of this, find T. Again, this is what I'd like to call snowman method. It's not really a real thing, but R is an endpoint at -6, -1. S is the midpoint at -1, 1. We're looking for T. So again, the 3 coordinates over top of each other kind of look like a snowman. We have to look for the difference here and do the same difference to get to the other end because the midpoint is halfway. So if we go the same direction we did to get to the midpoint, we should get to the other end point. So here we added 5, so add 5 more, and we're at +4. Here we added 2, so add 2 more, and we're at +3. So our point is at 4, 3. On the back. Number 8. Find the coordinates of the midpoint of EF with endpoints there. So again, you're doing an average. If you average those, you get that plus this is 2 divided by 2 is 1. Add those together, you get 4. 4 divided by 2 is 2. That's our midpoint. Again, you could do it in your head. Again, if you show work and make a mistake somewhere, the work will get you partial credit. B is the midpoint of AC and has coordinates. B is the coordinates. So, same thing as number 7 that we had just done. Again, you could do the snowman method. This is our starting point. This is the midpoint. So, -8, -2, -2, +4. Again, difference between these two, we went in a positive direction, +6 units. Go another +6, we get +4. Between -2 and 4, we went 6 again. Add 6 more, and you're at +10. That's our point. B is the midpoint of AC. It tells us this and this. So they give us the 2 measurements. If B is the midpoint, that means these two have to be equal. Therefore, we should be able to find the length of all 3 of those parts. So we could set these equal. You will have something like this on your test. So subtract the 2x, you're left with 2x. Add the 2, you have 6. Divide by 2, you have 3. Plug them back in. So AB, if we plug in for this equation, we'd have 4 times 3 minus 2. 4 times 3 is 12. 12 minus 2 is 10. Well, once we know AB, we should know everything else because BC should be the same length at 10. And AC should be double it because it's these two added together, which is 20. We don't have to do that much more math. We don't have to plug it back into every equation. Explain steps needed to construct a perpendicular bisector. So we've done this several times throughout the notes. Again, you need to make sure your compass is more than halfway. Swing compass above and below segment from both endpoints, connect to arc intersections. So that's a very short version of the steps. If you have questions on that, go back and watch the video earlier. Number 12, F is between E and G. So, all right, I'm going to have to stop the video. I got to go to Adult Ed. So I'll try and post the rest of the answers later. I'm not going to be able to finish this video on here. Most of what's left on here doesn't really need a whole lot of extra explanation. But again, I'll try and post the rest of these answers later while I'm working in Adult Ed.